Welcome. Remcom's XFdtd fully arbitrary 3D electromagnetic simulator includes the capability to import CAD geometries in many popular formats. File formats available for XF include ODB++, SAT, DXF, and STEP. Let's start with an import of a PCB in ODB++. For this import, we select PCB from the XF Import menu. Then point to the desired directory with the ODB++ information and select Choose. The ODB++ Import menu shows the structure being imported and offers several tabs for further specification. The Crop tab allows one to select a subsection of the CAD structure for import. First, we zoom in on the structure and then choose the lower right corner. Click and drag the mouse to draw the rectangle that selects the area to import. The import includes materials. Setting the green substrate material invisible helps us see the shape of the metal traces and planes. Once we import our CAD geometry, we can still parameterize and modify it. Let's say we want to widen this part that is related to an antenna stub. When we highlight the part, we see outlined in red everything associated with the part. With XF, we'll be able to modify one vertical face within this geometry grouping. First, let's define a parameter for the stub tuning offset. We'll call it offset and set its nominal value to 0.4 millimeters. Next, we'll use offset faces to move one vertical side of the metal up or down to narrow or widen this stub. We choose Modify and then Offset Faces. Then we click on this part to select the model. Next, we select the face. Finally, we go to the third tab and put in the actual offset value. When we type in the parameter name and click Done, we see the face move. This modification can be simulated with a parameter sweep over multiple values of offset for optimizing a design. Then if we decide we don't like this modification after all, we can go back with the Undo button and cancel it. The ODB++ import that we just did included the materials. Further steps in a typical workflow include assigning the excitation sources, specifying the grid, and adding sensors, which determine the data that gets saved. Next, we'll look at the CAD Merge capability, which allows updates to just the parts that have been changed since a previous version. Let's look at XF's CAD Merge capability with a via field geometry for high-speed digital signals. Starting with the new XF project, the available input CAD file formats include SAT, IGES, STEP, ProE, CATIA, and DXF. Let's bring in a STEP file representing a portion of the pin field geometry. Once this file imported, we can see an incomplete via field with 4 rows and 3.5 columns. Notice the parts list in the project tree. Next, we'll import the updated and complete geometry file for this via field and demonstrate XF's CAD Merge feature. This file being imported contains all of the via field geometry, including what has already been imported. Checking refresh and merge existing parts means that XF will only bring the new geometry parts into the project tree. Here we see the entire 4-row and 5-column pin field and the complete parts list on the left. None of the parts are duplicated. For comparison, let's import the complete geometry a second time, but this time without invoking the CAD Merge feature. First, we'll delete the geometry. This time, we won't check the refresh and merge existing parts box. We see the entire geometry get imported in one step. Notice that the groups area of the project tree gives us notes and details on the CAD Merge. Briefly, on the larger topic of workflow and layout synthesis, this pin field geometry can be drawn in XF with a JavaScript that was generated by a third-party synthesis program called Pin Builder. The XF project generated by this script includes ports and materials. Automation using scripts is very powerful in XF. Summarizing, XF imports ODB++, SAT, STEP, IGES, DXF, STL, and more. XF also has the ability to merge and update geometries with subsequent imports. For more information about XF simulation and CAD import, please contact us. Thank you for using XFdtd.